Good morning, Year 12s. Today we're going to look at how to find the local max and min, and how to find increasing and decreasing functions using Trig. The plans we looked at previously with polynomials and exponentials apply to Trig also. So if we want to find the increasing and decreasing intervals, let's look at this function here. So here, the first step is differentiate the function. So we want to find f dash x. F dash x is going to equal 1, take 2 cos x. Alright, then we want to solve for when this is equal to 0. 0 equals 1 take 2 cos x. Now, that looks scary. But if you remember how to solve trig equations from year 11, you take 1 from both sides, and then you divide both sides by -2. Divided by -2, you have a half equals cos x. And you should be thinking, well, that seems a remarkably neat result, a half, and that's where you need to say, yes, it's good, because we need to remember here, our special table, cos equals a half when the angle is pi on 3. So, to go back here, we know that this solution occurs at cos equals pi on 3. So one solution is when x is equal to pi on 3, cos x is equal to a half. But if you remember the unit circle, and pi on 3 is about out there, pi on 3, that means this gap here is a half. Alright, which is fine. So that means the derivative is equal to 0 when x is equal to pi on 3. That works well. However, note the domain is between 0 and 2 pi. Between 0 and 2 pi means that's one full rotation. If we have one full rotation, recall from year 11 that this here is another solution. So if it's 1 pi, 1/3 pi that way, it's also 1/3 pi this way. The entire thing going around is 2 pi, which if we're thinking in thirds is really 6 pi on 3. If it's 6 pi on 3 and we're 1/3 back, this angle in red is 5 pi on 3. So our second solution is 5 pi on 3. And it's very, very common in these type of questions for Year 12 Methods students to get this first one, because it's sitting on a table in front of them, cos of x equals a half, x must be pi on 3. But what they don't do is draw a unit circle and find the other solution or solutions. So it is absolutely vital here you find both solutions, and there will almost always be more than one. Sometimes there may be 4 or 8 or 12 or 6. Scary, but the unit circle is a vital part of your working here, and I can't stress that enough. Alright, now we have to draw a sign diagram. So the sign diagram for this, f dash x is equal to 0 at some points. It's equal to 0 at pi on 3 and 5 pi on 3. Alright, 0 at pi on 3 and 5 pi on 3. Now, cos here is... Alright, so then we need to sub back into the original equation. No, sorry, where it's increasing or decreasing. We're not finding max or min. Increasing or decreasing. We need to find out when this is going to be positive and when it's going to be negative. So, if we sub in a value, say here, which is less than pi on 3, say pi on 4. If we sub in pi on 4 to here, we can use our calculator to figure out whether it's positive or negative. Now, I can tell you there it's going to be negative. But you can use your calculator to check. Positive, negative. These are the portions where it's increasing and decreasing. And to check this, you can look on the calculator. And we check on the calculator. It's a good thing we checked on the calculator. Or I really should have checked by subbing that value in first. Look here. This is where it peaks. Dropping, peaking. Alright. Now looking there can look kind of scary, because it looks like, and it scared me because I just thought I got it wrong, but it's to do with the view window. So it looks like it's increasing here, decreasing, increasing, and then we lose it. So here it's really good to start restricting the domain. We remember that our original question restricted the domain between 0 and 2 pi. So the domain is a good thing to help you set your view window. View window goes from minus 3 pi to positive 3 pi. I want it to go to 0 and then 2 pi. Let's draw that. Alright, so we can see it's decreasing to start with, and then it's, well, zooming up, we're not sure what's happening. So let's look at the view window and set this much higher, say 10. Alright, now we've got a better graph. And what we can see is that this graph here is decreasing until a certain point, and then it begins to increase. So if we want to find those certain points, we go gsolve min. Now, min is 1.01 something, and I bet if you put your calculator pi divided by 3, you're going to get 1.0 something. Similarly, if you have a gsolve max, 5.23, if you put 5 pi divided by 3 in your calculator, that's the max point you're going to get. So the intervals it'll increase and decrease over are decreasing between 0 and there, increasing and then decreasing again, and you can see that on the graph. Alright, your calculator is a big friend to you here, helps you sub in, also helps you graph. But your calculator can't do some things, like it can't find the exact solutions here. You need the table and the unit circle to do that. So it's about knowing when to use your calculator and when to graph and when to check using the graph. Alright, I'm going to skip that for now. No, I'm not. We're going to go back to it. Alright, so here we want to find when f of x equal to cos 3x between 0, with x between 0 and pi on 2. Now these ones are always hard because there's a 3x in here. Alright, and I've printed out a website answer to this, but I'll do it over here myself. So you can read through the website answer if you want, or try and follow my logic here. Let's solve this, or differentiate it. F dash x is going to be 3 minus 3 sine 3x. And with x still between 0 and pi on 2. Alright, now we want to set this equal to 0 and solve. 0 equals minus 3 sine 3x, once again in this domain. And the reason I keep mentioning the domain is because in year 11, and I'm not sure if you've covered this or not, but it appears in the supplementary videos, you need to work out how far around the circle you can get with a 3x. So here, 3x, when applied to this domain, will have values of between 0 to 3 pi on 2. So that's really 3/4 of the circle. So if x is equal to the maximum here, if x is equal to pi on 2, then what you've got is 3 times x, which gets you to 3 pi on 2. So we'll do some more practice with these, but essentially it's about knowing that that domain lets you go further around the circle than just the pi on 2 because you've got a 3 there. Alright, let's solve this directly. So what we'd be thinking is, well, minus 3 doesn't really have an impact here. The only thing that would be equal to 0 is sine 3x. So 0 equals sine 3x. Now, from the table, we should know that, say, sine, if we had sine A equals 0, A would either equal to 0 or minus pi. Alright, now, the reason that works is, well, other than being in the table, is because sine is equal to 0 at this point and this point. Did I say minus pi? Well, it is at minus pi, but positive pi makes more sense. Those 2 points there, because that's when there's 0 up for sine. So what we can say here is that, well, 3x must equal to 0, or 3x is equal to pi. So x is equal to 0, or x is equal to pi on 3, as our two solutions. Alright. And the reason that works, the reason there's two solutions, even though x is between 0 and pi on 2, is because if we extend the circle round 3/4, so 3/4 of the circle, that's this extension here, we're going from here around to there, and you can see we're hitting both of those dots with the solution points. Similarly, if we had 2 points here that were solutions, we get them both as well, even though we're not in that fourth quadrant. Alright, so our two solutions are x equals 0 and x equals pi on 3. So if we're looking for increasing and decreasing portions, we can look at f dash x and draw a diagram here. We're going from 0 up to pi on 2, and critical points are going to be 0 and pi on 3. It's about there, pi on 3. Alright, now the question is it increasing or decreasing to start with? Well, our calculator can certainly help there, or we can choose something to sub in. I personally would choose something to sub in, so choose something in here that would make sense between 0 and pi on 3 is pi on 6. Pi on 6 is, well, if you do pi on 6 times 3, pi on 6 times 3 is 3 pi on 6, 3 pi on 6 is pi on 2, sine of pi on 2 is 1, minus 3 times 1 makes that negative. And it would be worth checking, but that would be positive there as well. So we're thinking it's decreasing between 0 and pi on 3, and increasing for the rest of it. And you can check on your calculator, and that step there that I did in my head, you guys would quite comfortably do with the calculator. Alright, local max and min. I think just one example here. I lied, 2 examples. Hang on. Alright, the plan is same as before. So here, find local max and min, we differentiate the function, solve for f dash x equals 0, use a sign diagram to determine the nature of the stationary points, where they're maximums, minimums. We sub the solutions into f of x to find the coordinates, and then we can check. Note that one option here is for us to simply graph the calculator, and gsolve max and min gives us the max and min points. However, often that won't give us the exact points. So here, f dash x is equal to e sine x multiplied by cos x. Alright, we want to solve it equal to 0. 0 equals e sine x times cos x. And this is where your knowledge of functions really comes in handy. So null factor law, we've got two things multiplied together. One of them must equal 0 for the whole thing to equal 0. E to the power of anything can never equal 0. So all we're really interested in here is when cos x equals 0. Cos x is equal to 0 within this domain. We can draw a circle. Circles are part of the writing. Cos x is equal to 0. Cos is the distance across there and there at pi on 2 and 3 pi on 2. So our solutions are x equals pi on 2 and 3 pi on 2. Then we need a sign diagram for f dash x to check out the nature of the solutions. 0, pi on 2, 3 pi on 2, 2 pi. Alright, so we choose something that goes in here, say pi on 6, because pi on 6 works quite nicely with the original function. Sub in pi on 6, that'll be positive, it's going to be positive by pi on 2. So above pi on 2, cos is negative, means the whole thing is negative, and cos becomes negative after 3 pi on 2, so positive again. So what we're looking at here is a max and a min, and we can check that on the graph. Now to find the actual points, we would have to sub these two values back into the original equation to get the solution. So let's do that. So if we sub in pi on 2 to where x is, we have y equals e to the sine pi on 2. Sine pi on 2 is 1, so it just equals e. Y equals e to the sine 3 pi on 2. 3 pi on 2 is minus 1, so it equals e to the minus 1, or 1 on e. So our points for are pi on 2 e, 3 pi on 2, 1 on e. And there's no way a calculator can tell you that, but what you can do is find decimal approximates for both of them. Once you get the decimal approximates, you can find max and min and make sure your decimal approximates line up with those, and that way you know you've got it right. Alright, so same plan as before, just this time with E and trig. Alright, Last question. Apologies, it's taking a while, but you did ask for harder questions in there, and so we're going to put harder ones in. Let's find dy dx. Once again, we're going for max and mins. That's cos x minus sin x. Alright, and we want to set this equal to 0. 0 equals cos x minus sin x. Now you're thinking, well, whoa, what's that? This is a trick that does come up occasionally, and I think I've just cut this question out of the textbook, so I think it's worth you seeing. How do we solve this? The trick is going via tan. So I'm going to add sin x to both sides. Cos x. I'm then going to divide both sides by cos x. So the working will be divide by cos x. Divide by cos x. And that seems like a really odd thing to do. But on the right hand side, cos x divided by cos x is 1. Sin x divided by cos x, well, sin x on cos x is tan x. So what we can do is we can take quite an ugly equation like this and turn it into something nicer like that. Neat, huh? And then we can go back to our table and think, when is tan x equal to 1? Tan x is equal to 1 when the angle is pi on 4. So our solution is x equals pi on 4. And if there's just one solution, you're immediately suspicious. And as you should be. Tan of pi on 4 occurs there when the tangent is equal to 1. That makes some sense. Alright. The other ratio, or the same, occurs to the tangent on the opposite side. So that tangent and that one there are both equal to 1. So what we have to do is add pi. So adding pi onto there is 5 pi on 4. Those are our two solutions. So those two solutions are where the max or min or stationary points occur. So once again, we do a sine diagram for f dash x, or dy dx. Sine diagram goes between 0 and 2 pi. What we've got is pi on 4, 5 pi on 4. Now we need to know if it's negative or positive. Sub in, solve. You guys can carry it through to the end. Alright, but the real purpose of showing you this was that trick there, which I think is pretty neat. Alright, thank you for staying with me so long.